So, just a little bit quick background on the colloquium. First of all, we're extremely glad that we can hold it today, considering what's going on outside. It's been an incredible kind of last-minute change and shift to try to make sure that those people that were able to make it and are here are able to present to you guys, and also to carry on a discussion that I think is really interesting. So, just a motivation for the colloquium. I think some of you also have attended a symposium earlier this semester that was conducted by Sean Lordholder that dealt with the literal landscape, looking at coastal areas. This is another one, trying to get a group of people together to talk about an issue that I think is going to be very significant and important as we start looking at new building technologies. This is about a material, ceramics and terracotta, and looking at how people are working with this material, but also starting to think a little bit about the efficacy of using a material that basically is dirt on the one hand and has an incredibly interesting history within architectural production. The closest thing to stone, so a lot less embodied energy to produce it than we do with steel and all other materials that are part of the kind of modern palette. At the same time, there's a lot of experimentation that architects and engineers are doing with this material that would suggest that it's not just a kind of straightforward material, but has tremendous variety. You can shape it, you can form it, you can glaze it, you can do a lot of stuff with it. And inherent in it are other performances, which we hopefully will also look at. Things like the ability to sort of retain heat and cooling, as well as other qualities of longevity, as I said, close to stone, etc. So the motivation here was to, a colloquium is basically comes from colloquy, which is a conversation. I was interested, as well as the other organizers, that's Laura Garófalo, Stephanie Davidson, who's here, and Georg Rafailidis, who will hopefully be joining us a little bit later. What we really were interested in was a conversation across art, architecture, and engineering. To a large extent, I think we've got the art and architecture covered. Our engineers, who are coming up from Alfred, were unfortunate to hit the wall of snow, and so are unable to make it. So that's an unfortunate part of it, of having lost a few members in the participation of this colloquium, but hopefully we can carry on, and some of those issues we will look to kind of address again in the next semester, try to bring these engineers in. The colloquium's hope is that by talking across these three areas, between art, architecture, and engineering, that we come to appreciate this material in its variety. We come to sort of understand how we may use it creatively, but also technically, and some of the affordances. What we'll sort of hopefully find is the unique affordances of this material may not be necessarily easily presented from just the architectural or the art side, but may be necessary to understand it on its property side from engineering. So originally we had a nice large group of people that we were going to be able to have, which was a large 3 parts, a panel on context, process, and now what we have sort of been able to sort of reduce it to and be able to sort of address just the core of people that are here, is to just look at these 2 parts. So performance is a little bit missing because our engineers aren't here, but we'll look at context first. Miguel Guitart will start us off, Brian Lilly will follow with that, and then Ariel Bryce. Miguel, of course, as you know, is a faculty member here in architecture, teaching in the junior year. Brian Lilly is joining us from Dalhousie. Brian is a professor of architecture at Dalhousie University and has been doing some very interesting experiments with lots of materials, including terracotta. Ariel Bryce, who is here, is joining us from Milwaukee. At Madison. And Ariel is a ceramic artist, and he will speak from that point of view, looking at the particular ways in which he's thinking about the material and using the material in his artwork, but also maybe projecting a little bit. We'll then have a small break. We'll have a discussion with the three of them, and then have a small break, which will be followed by three more people. Joshua Stein, who's joining us from Woodbury in LA. Joshua's work deals with 3D printing of ceramics, followed by our very own Stephanie Davidson, who teaches here, who will look at a very particular kind of performance of the thermodynamics of the use of terracotta. And we'll end with Peter Schmidt, who is from Boston Valley Terracotta and a UB alum, just graduated last year, showing some of his thesis work, but also the interesting work that they are now doing at Boston Valley Terracotta, working with the University of Buffalo. Okay, to start us off, we'll have two moderators. So the first one, Mitchell Green, I might be Mitchell's back there. So Mitchell, some of you know, but those that don't, Mitchell is a research faculty here in the department. He's our liaison with the Boston Valley Terracotta company, and he'll moderate this panel. Mitch.
I'm glad to see so many turn out. I'm from the Banana Belt of New York down in Westchester, and in the 4 years I've been coming up here, this has been a surprise. I've never understood how discrete the snowfall really is. I've been stuck in a hotel in Midtown with about maybe 4 or 5 inches, but Boston Valley Terracotta is an orchard park, and we have 60 inches. And our colleagues one of them was trying to fill up his car with gas, and state troopers said, "Hey buddy, what are you doing now?" So they're not going to be able to join us. You can't go against both the force of nature and the state police. Real quickly, I have been very fortunate to be affiliated with UB in Boston Valley over the past several years. It started with the National Historic Trust visit here. I didn't know much about clay past my Play-Doh extruder days, and but I was very interested in CNC machines. And visiting Boston Valley a few years ago was like going into a Dickens novel. They were doing all of their survey work with wooden calipers and rulers, and everything was being done by hand. I mean, everything. The primary material processing system in the building is pushing railroad carts or down everything. Because of the affiliation with UB, myself, and some of the students who have interned, we've changed that company. Boston Valley is the only North American manufacturer of terracotta rain screen, which is now in vogue for a lot of reasons. Their competition is all European-based. We have someone speaking about the traditions of European ceramics. There was a time at the turn of the century where it was a big industry in the United States, but between the Depression and modernism, there are only 2 manufacturers of terracotta in the U.S. of any scale, one being in Sacramento, California, the other being in snowbound Orchard Park. We've done some amazing things, the students and the company together. We've instituted 5-axis CNC machining. We've instituted photogrammetry techniques for doing on-site measurement. We are changing, and now the leaders in that industry. We are not capitalized as well as the European competitors, but we are winning a lot of the jobs, not only on price, but on quality. I use the word we because it's hard working with a bunch of dedicated folks who are that much fun to work with and share the common sense that we are making progress. For those of you who have the slightest inclination, either interest in turning those rhino grasshopper scripts into something that can be built and will be built, for those of you interested in measuring the thermal performance of a building, you can choose glass, which is non-recyclable once they put in the heavy metals. You can, lower the E-value of the material. You can choose a lot of things if you're interested in sustainability, or sculpture, or robotic vision. Come see me after the lecture. We have a whole, assembly line, bad analogy, a whole way of cultivating talent and putting you to work as soon as you want to go to work. So that's a unique opportunity. Two former students in the back are UB graduates. We currently, the company employs 4 UB graduates, about to hire a graduate student. There's a lot of ways to change the world. This is one. So I'm looking forward to seeing you. Enough about me. I really don't know the work of the people who are going to speak. So I'm looking forward to learning, and then perhaps we'll have some intelligent or interesting questions. Okay, so first up is, let me look at my revised schedule, Miguel. Speaking about Spanish material.
Okay, well, hello, thank you. In first place, I want to thank you Boston Ballot Terracotta for their vision and their support. I want to thank the organizers for so much work and all of you for joining us today. I'm going to try to talk about the context in not necessarily in Europe, but in Spain, where probably the tradition has much to say to what we're dealing with today here. So there will be a number of loose images, and I don't pretend to talk specifically on projects. I just want to have an overview and a general vision of what the history, the tradition has been transformed into the contemporary in Spain. The ceramic industry in Spain is then not a matter of the past, but it's a vibrant attitude that has its roots in the most traditional vernacular architecture. This tradition has evolved into a contemporary approach in a very natural way in all Spanish regions. And we could say that a regular use of ceramics appears in many interesting architectural proposals and in construction resources that belong to the past and to the culture itself. Spain is a country with a very strong tradition in the use and application of ceramics. We could start this story with the Phoenicians, a prosperous culture that thrived throughout the Mediterranean between the 1500 and 300 BC, with some very relevant enclaves in the Iberian Peninsula. The ceramic work always gave the possibility of a very cheap, easy-to-work material that found its place in everyday life, in everyday use, like popular construction utensils, kitchenware, and so on. Today, Spain is widely recognized for the immense tradition of these works that, even though they belong to everyday use, they've become a big expert industry in the country in material and artistic terms. I would like to start or remark the important influence of the Islamic culture for more than 7 centuries in Spain. From the 8th through the 15th century, 711 until 1492. In a piece of land that was not yet known as Spain. What you're seeing is the Alhambra. The Alhambra in Granada, built in different periods, but mostly in the 14th century, that sits atop one of the heights of Granada. This red fortress, which is what Alhambra means, is a perfect example of architectural and cultural refinement that was actually designed and built with very common, sometimes even poor materials. The use of ceramics was widespread in the Alhambra, and its construction produced some overwhelmingly rich spaces. The ornamentation of these rooms would be a consequence of the work and application of very basic materials like plaster and very especially ceramics, both glazed and not glazed. More than 4 centuries later, we see some of this influence in the Plaza de España, the Plaza of Spain in the city of Seville. Built in 1929 as part of the Ibero-American exhibition. Here, the ceramic tile was widely used in this work in many different forms, flat and textured, painted, glazed, and so on. Even though this project by Sevillian architect Aníbal González will probably not dictate what the coming modernity was going to be, the application of ceramics was clearly symptomatic of the way such material had permeated all levels of culture throughout the centuries in Spain. Early on, Rafael Guastavino, who you may know, a Spaniard who moved to the United States at the end of the 19th century from Valencia, the east of Spain, was having a great success in this area, actually, with a construction system that in Spain, especially in the northeast part of the country, had been widely used for many years in vernacular and popular architecture. That was known as a volta catalana or Catalan vault. This construction technique can be traced back actually to the 14th century in Spain and consists of ceramic pieces arranged in a specific disposition that generates extremely resistant and stable vaults. This is an example of a vernacular house. We'll see this example here for some stairs in the construction process. Extremely resistant and stable vaults with barely any thickness. Once again, we witness the evolution of a system that is cheap and extremely low-tech. Here we're seeing some of the examples. This is the National Museum of Industry near Barcelona. And these are more contemporary exercises with the same approach. Early on, at the turn of the 20th century, a master like Antonio Gaudí was working with the trencadís. The trencadís is a colorful and decorative pattern made out of recycled ceramic pieces that resulted in a cheap and colorful finish in his architecture, including that sometimes in buildings that were for the aristocracy of Barcelona, like the Milà house. Gaudí was a key architect of modernism in Spain, and his care for the details, the rich use of the materials, the almost impossible array of forms and colors are quite visible in the way his works were finished with these patterns of irregular and colorful ceramic pieces. The trencadís was very often taken from residual pieces or remnants of other works, and it became very popular with Gaudí, but it certainly belonged to a centenary tradition in most areas of Catalonia, Valencia in this coast, and the Balearic Islands in the Mediterranean. Pablo Picasso, you all know about him. Pablo Picasso himself worked very often with ceramics, a basic material that to him related to the very essence of mankind, making it a magical material to work with. The relationship Picasso had with primitive arts, both in the graphic expression and the type of materials took him to explore this artistic option in a very serious way. The pieces that Picasso made with ceramics were not just a few, but a very important portion of his work. Again, Picasso was taking a cheap and common material into the level of art, therefore emphasizing the greatness and the relevance of such material in the Spanish culture. The ceramic production in Spain has gradually continued to grow and improve. It has become a whole industry that exports throughout the entire world. We could say that the Spanish ceramic industry today is a big asset in the economy and has a relevant presence worldwide. Companies like Porcelanosa, Malpesa, or Roca, who you probably know, among others, have a strong, very strong international projection and have been able to even implicate Prince of Wales and celebrity Isabel Preisler. Prince and Isabel Preisler. Isabel Preisler, a former wife of Julio Iglesias, who you probably know. They actually attend an annual event in London that is hosted by Porcelanosa. This point could actually be taken as a funny thing, but it gives an idea of the kind of social relevance that such a ceramic company has achieved today. Their tentacles also reach out Hollywood actor Patrick Dempsey and other famous people, therefore extending the association of quality and design to international markets, to the point of including the Plaza de España that we've seen before in Seville as a setting location for the Star Wars series. Here we have a couple of images of the Phantom Menace and the Attack of the Clones, where the city of Thebes and the planet Naboo are recreated in the Plaza de España in Seville. Today, we can talk of a recent evolution in Spanish architecture, where ceramic has evolved into a contemporary material through which not only new decorative or ornamental surfaces can be explored, but also, and most important, new spatial qualities. We find many examples, like the ones that we are seeing very quickly, where a renovated, more experimental approach with ceramics has resulted in unexpected solutions with extraordinary results. Applied in a more or less sophisticated way, ceramics are, in Spain, like have always been in its history, a key element for the exploration of architecture. I would like to insist on the fact that when we think of ceramics in Spain, we must remember the relation of the material and the techniques with the vernacular and the popular environments. In this context, and I'm going quickly, but I just want to have this overview. In this context, we may find pieces of architecture as simple and yet as powerful as one that I'm going to show in a moment. Like this tobacco drying bar in Toledo, Spain, a construction that is now abandoned, but that still displays an extremely valuable interest, given not only the scale, but also the simplicity of the construction process and the qualities of the spaces inside. This building was built sometime between the 50s and the 60s of last century and can now be seen from a secondary road. To me, it is impressive to experience the way such a functional vernacular piece of architecture can have so much interest in terms of abstract composition, scale, layers of space, and layers of vision. quickly now would like to go through a few contemporary projects that I will not explain in detail, but I just, because we don't have time for that. Among other optional categories, I selected 3 that I understand are critically interesting in the last 10 years of the architectural production in Spain. These categories have to do with the surface, the artistic approach, and the spatial qualities. In the surface category, I would like to show 2 examples. This is the first one. This is the Santa Caterina market in Barcelona by Enrique Miralles, now EMBT. This was finished in 2004. And the market considered the rehabilitation of an existing market and the construction of some housing for seniors at the end of one of the sites. Just in case you visit this, that's also part of Miralles' work. The idea was to create a singular roof that could be enjoyed by the housing around the market. And by doing this, to offer a landscape of colorful rolling hills to the buildings around. At some point, there was even some discussion about permitting public access to the roof, but this did not catch on due to safety reasons. The second project is the Sea Promenade in Benidorm by Carlos Ferrater. Ferrater goes for the OAB, Office of Architecture in Barcelona, and this project was finished in 2009 and is a singular undulating maritime space. It was created as a transitional area between the city and the beach in this Mediterranean city. A landscape promenade that was designed as an intermediary space where color had a key importance. The concrete contention walls were inspired by the dunes of the sandy beaches, and along its changing landscape, a series of complementary functions, like accesses to the beach, seating areas, bicycle parkings, showers, etc., were organized. The use of the colorful ceramic pavements along the intervention recreated an artificial landscape that confronts the natural one of the beach. In the second category, the category of artistic approach, I would like to show a very particular piece that can be considered very relevant space halfway between art and architecture. You probably know Rafailidis, the artist born in Mallorca. He was asked in 2007 to design a proposal for the interior of one of the main chapels of the Gothic cathedral of Palma de Mallorca in Spain, the Balearic Islands. Such a big commission was not new to one of the most extraordinary architectural pieces of the Gothic period in the island, because in the case of the cathedral is very particular because it contains a number of collaborations, like this sort of floating element on top of the main altar made by Gaudí himself. Miquel Barceló proposed a dramatic 3,000 square feet ceramic solution for one of the lateral chapels that represented parts of the parable of the loaves and fish from the Christian gospel. What he did is to wrap the entire Gothic space with this permanent installation that is completely narrative in the way he explained this parable. The wrapping of the old walls with a new artistically treated narrative ceramic skin has obviously become a characteristic element of the cathedral. Barcelona has traditionally worked with earthly materials through his production and has been profoundly attracted to some original cultures, for example in Africa, where he actually owns the house and spends time painting and sculpting. It is very interesting to see that an artist like like him, has developed a work of art like this, where ceramics have been modeled to implement such an expressive and innovative character to the Gothic space. Like we saw with Picasso, it seems like ceramics continue to be a critical medium of expression for Spanish artists. In the last category, where spatial configuration of space is achieved through the manipulation of ceramic elements, I would like to show three examples. The first one is this Pavilion of Spain for the international exhibit in Aichi, Japan in 2005 by Alejandro Zaera, FOA until recently, Foreign Office Architects, now AFPA, AZPA. This pavilion was designed with the idea of a permeable skin that would act as an intermediary between the inside and the outside by changing the degree of porosity. The closed and open deformed hexagonal pattern was made out of glazed colored ceramic pieces that would allow Zaera to work explicitly with the envelope. Something that he is actually very interested in. The final material production of the pavilion was, in this case, a very appropriate representative of the Spanish culture. The second project of this last category is this building for offices in Toledo, Spain, by a young group called Graña and Bernalte. It was built in 2008 near Madrid. It was conceived as a versatile container for young professionals and small startup companies. The architects gave form to new spaces inside by using a very simple solution that displayed an unusual arrangement of ceramic pieces in the facade. This arrangement hides wide hallways, you see here, that belong neither to the inside nor to the outside, and that contain all circulations and push the glass enclosure far from the ceramic skin. This poses a great passive solution in a place like Toledo, where the sun and the heat are key factors to be considered in the design. The facade allows for continuous ventilation where direct sunlight is kept away from the offices inside. And finally, the Spanish Pavilion in the Expo 2008 in Zaragoza, in Spain, by Pachi Mangado. You probably know this building as it's being published very thoroughly. The building was organized as a basic container with a surrounding forest of columns that were entirely cladded in a ceramic skin. The main idea was to create some sort of hypostyle perimeter, a buffer zone that would hide the glass box inside, again, from direct sunlight. Here we have the plan. Besides this, some of the areas outside, especially those where visitors would have to line up to enter the building, had columns interacting with water to favor the evaporation process and therefore cool down the temperature near the building. This approach happened to be a success, and the building stands today as one of the most celebrated projects of the Expo and also of Mangado's career. I would like to conclude this quick overview with a praise of the ceramic material because it belongs to the past, but it also belongs to the present. I have tried to illustrate very quickly that it's also possible to make it part of the future, as ceramic solutions bring the possibility of working with an expensive material that has infinite possibilities, whose application today, more than ever, makes a special sense as it seems to be a perfect material for where tradition and sustainability can be combined with a contemporary abstraction and a sustainable approach to the way we use energy. If these Spanish examples have been inspired, then I invite you to discover more about Spanish architecture. Thank you.
Well, good afternoon, everyone. My name is Brian Lilly. I teach at the University of Dalhousie in Halifax, Nova Scotia. And I must say I had a very painless journey here. It was no problem at all. Quite sure. Felt like it. The project I want to present to you is, I would say, an interdisciplinary project. It really is derived or results from 2 or 3 strands of knowledge coming together. It was originally conceived of as a project in response to a challenge called material intensities and smart geometry in Georg. So at my university, myself and a fellow named Roland Hudson, we are architects, instructors. We're both interested in material and in computation. And Kevin Pluckett, however, is an interesting fellow. He's a material engineer. He holds the Canadian Research Chair in the breaking of ceramics, so obviously interesting. And together with one other fellow, Rory McDonald from NASCAD University. And it was great to have him on board. He had a lot of very interesting ideas about ceramics that we tried to bring to the floor. And NASCAD University, it might be that Neil Forrest appears, it might be that he doesn't, but it is an excellent facility. The keynote today is also from that university. We have the great pleasure of being able to work with them. They have an excellent suite of buildings. So it allows us to both talk about work in architectural terms and also to really get on with trying things out. So the places where we started, we were quite interested in material development, scales of testing, and knowledge and tool sets. And we started with a very simple wax molds, and we were also doing work in processing at the same time. We started to look at the idea of accumulations of moisture with the material. Environmental responsiveness had played a great deal in the formation of this project. The references that I would bring up would be 3 things, I think, in relation to architecture. One is the Chapel of Reconciliation. This is done by an architect named Peter Sasanoff. He turned a very small budget into a very beautiful building, I think. It is essentially a round earth composition made up of the remnants of a cathedral that was blown up. It had sat in the space between the walls. The building in the center is one that I spent many years working on in Berlin. It's called the GSW headquarters. And this building was like a machine for moving air, if you like. It was very finely calibrated to natural air movement. And in a sense, there's a kind of a correlation with the way this project moved. The third one was a very small kind of almost detail, if you like, but a water filter designed for townships in Kenya. This was actually done at the University of Alberta in the medical faculty, and they discovered a solution of using colloidal silver as a means of, say, an antibacterial agent, which would allow that water filter a life of about 15 years. And more importantly, it actually started an industry. So this idea that you can seed an industry, I think, is a very interesting idea. It is a great thing. So this is one of my favorite quotes from Marina Banham. I think it's absolutely true. Environment management, humidity. This is a great word, huh? Pestiferids, I think. It's subtle and elusive control. And For us, you know, we who live around the Great Lakes or in maritime climates, this is an incredible phenomena that our comfort is actually very dependent, I think, on how we handle humidity. And then the amount of energy that we take to actually handle that humidity. So moisture flow through assemblies. You know, this idea that every building would have, or every building material would have a perm rating, that we actually analyze an assembly on how moisture penetrates through it. It is very interesting to say the positioning of vapor barriers or the types of vapor barriers in building assemblies. And that was one of our starting points. Another kind of question about, say, porosity in ceramics is this idea of what are ceramics and what are their attributes. There's an engineer in, oh, you can see here, in England, a fellow named Ashby, who's developed a great set of charts dealing with attributes of materials. This is actually showing in the upper left-hand corner, upper left-hand side. We're looking at Young's modulus, so say the strength against the density of material. Very good to know if you're specifying materials and the amount of deflection. And we see that there's a kind of a chart of, say, from high-tech to low-tech in these values. And essentially, technical ceramics, which is like a very high-tech ceramic, occupies one part of that chart. But non-technical ceramics, such as we use in architecture, has a very good rating in its own right. For me, it was also very interesting to consider this kind of relationship to embodied energy. So not only are we looking at strength and density, so weights of materials against performance, but we're also looking at, say, more of a life cycle analysis. And again, we see that both non-technical and technical ceramics do pretty well, but non-technical ceramics, they're doing incredibly well in that regard. This leads me back to Kevin Pluckett. We started our investigations actually in his labs. This was done at a micron scale. This chart here on the right-hand side, you can see a basic kind of idea of scale that's happening. And what's quite interesting is around nanometer and up to micrometer. This is actually where ceramics seems to have its most relevant properties. So we're talking here about strength, we're talking about toughness, friction and wear, and then we get down into this idea of strength, electrical, thermal, and optical properties. So this is all happening at a very small scale. And fortunately for us, Kevin had done a lot of work at that scale. So a lot of the early experimentation was just to see if there was a way to find a gradation in a material sample, and then to see how much porosity would be in that material sample. This was done with small discs, and these were both fired and then tested in a laboratory environment. The great thing about this was that he had the tools, like the scanning electron microscope, to actually see the results, which is something that wasn't normally available to us. I'd just like to talk about Rory for a moment. Rory McDonald is coming from a complete other direction. He was talking to us a lot about in situ installations. And this idea that a dumpster could be a kiln, I thought was fascinating. So this is like another idea. This is almost like a street style ceramics, if you like. Somebody who's kind of very aware of what's going on. What attracted me a lot to Rory was this idea of the portable kiln on the far right at the top. He's made a kiln that you can actually take and install on site and then fire a piece of ceramics anywhere you like. So the main concept that Rory was talking about was an idea of multiple material states. And so it was asking us to imagine an architecture that embodied both, say, a material in its green state and material perhaps in its finished state, and what kind of resulting interactions would happen. We then kind of looked around a little bit, and maybe we went to Spain. I wish we'd gone to this building, but it's certainly on the list. A very interesting architect, Enrique Ruiz Helin, I think. He's designed a home for himself, Villanueva, outside of Barcelona, and it's been a kind of a long, slow process. But on the other hand, very fascinated with computation, what we can do, say, with parametric scripting. And then in the upper left-hand corner here is coming out of a fairly complicated geometry, all the ceramic tiles that would be needed to cover that surface. So these ceramic tiles, as you can see, they're divided into color spectrums, and each one has a particular role to play in terms of opacity, and also in terms of like a heat deflector sheet. The interesting part here is working with an artist named Omar in ceramics. I'm not sure how well you can see this, but each one of these tiles is individually finished with a patterning on it. So we took that as a kind of a reference point. And for ourselves, the project developed along the idea of, if we start with this idea of a human maritime condition, could we develop a tile that could take on many roles within that one wall? And so we were thinking about a situation where you'd be absorbing energy from the inside, and you would also be working with moisture or humidity from the other side. So, in terms of the multi-material state, what we came up with was an idea of a number of frames that were fired. You can see that we actually went through a number of prototypes, but in this section here in the lower left, this was the idea that we would have a frame, and then we would have a fill, and that fill would be a green clay. So we're working with, in this case, with two different ideas. One is, could we have a kind of a positive interlock and interaction between two types of clay? And then secondly, what would happen if we introduced channels to simulate kind of a draining or kind of a path for moisture or air through that panel? And lastly then, in terms of consideration, there was an idea of what happens on the surface and how do we handle water on the surface? So we started looking at a number of different powdering techniques for the surface energy. Yeah. So I guess the great thing was being able to work, as I was mentioning, with NASDAQ, and we then did a typical kind of development from CNC, styrofoam, tensite plaster, and then round press for the molds. And yeah, I mean, setting up a tensite mold is very interesting because it starts as something that is apparently dry, and then the air, the forced air kind of within that mold actually forces the moisture out. It happens very rapidly, but you know, for our way of thinking, that was started to illuminate, if you like, this idea that the material itself is actually a web of voids. So it's interesting because it starts as almost little bits of wispy humidity, and it turns into cooling to the point where that water actually flows right off the material. With these frames, then we have the use of a number of very sophisticated kilns, computational control over temperature and airflow over time. This represents a weekend of firing. And at the same time, we were trying to develop a model, like a computational model based on FlowNet, which is normally used to model aquifers, to see if we could start to understand how water may move through that material. And then, in homage to another one of the potential participants here, we also started to look at bentonite and this idea of the humidity flywheel, which Bill Carney can speak at length on, not so much me. But we also then became very interested in other tiling types. So, would anybody recognize this? Okay, tell us what it is, Omar.
That's the shuttle.
It is, it's the space shuttle. And this is probably the most high-tech of all ceramic facade systems. And it's an idea of a material that has a thermal insulating characteristic by increasing its conductivity. It's a solid matrix, and there's actually a gas within its pores. It's a good insulation property achieved due to very small thermal conductivity in gases compared to solids. So, in terms of the actual construction, the actual artifact though, the piece itself is maybe not that interesting because it's literally, it looks like a block of styrofoam. But then it has 2 or 3 different characteristics. You can see on the edges of the wings, obviously, the need more resistance. So to contrast the high-tech idea with a low-tech idea, we also looked at the work of Haas and Fathy, and this idea that there's a whole belt in the world that depend or, have traditionally developed ceramic knowledge or let's say earthen building knowledge. And what Fathy found out, or what his experiments really showed, you can see the dotted line on the top, and this is really the idea of the well-tempered environment. This is a comparison of indoor and outdoor temperature with the idea of time lag, so that the material would absorb the heat during the day, and then it would give it back at night. And then if you like, you compare it to the chart at the bottom. That's using prefabricated concrete slabs, and you can see that there's a bit more of an imbalance, say, that the temperature spikes and then does not release in the same, say, useful or well-modulated way as the material in the top sample. So this led us to another experiment. This is an idea of partial firing of clay. And what we have here is, this is an experiment from Kevin Bucknell. I'm not actually sure about it. And what we're looking at here is two examples of clay that have been done in very similar manners.
No, it doesn't have any proof connected.
It's an example of porosity that's done through partial firing. So the one on the left, 1200 degrees Fahrenheit, the water from the pipette, it just sits on the surface, where the one on the right would absorb completely. And that's only with 100 degrees difference in this scale of firing temperatures. The second aspect, when we start to examine like the block, now the second part of this block was this idea of directionality. And for core directionality, this is something that we're working on right at this moment. There's another novel technique that instead of firing clay to fix it, there's an idea called ice templating, where you literally take the clay body and plunge it into a nitrogen bath. And what that means is that then a whole line of dendritic crystals will form. And it's very interesting because that automatic plunge, that kind of shock therapy, if you like, that drives the water out of the material, but it does it in very linear chains. So, if we look at it in the micrometer scale under with the SEM, then we start to see these kind of long channels working through the materiality. So we thought that was very good, and that in a way is if the first sample that I showed you was about being a sponge and being able to absorb, then this was a means of directing excess water or excess moisture out of the material. The third property, if you like, that we were looking at was insulation. And here we've started to look at ceramic glass composites. This is like a foam or a closed cell to open cell transition. So in a way, what we've done is we've done some work in the laboratory, getting it toward a series of attributes that we'd like to see, and then we tried to test that with an analog. But where it's going, we considered was to be able to take a standard brick like this and to give it material properties that one could adjust to the climate and the situation that you're in. So in the first case, nonlinear porosity, this would be the sponge effect. And secondly would be this idea of directional porosity, which would allow the brick to bend, or you could actually move moisture or heat in a certain direction. And the third would be the idea of closed cell foam, good for absorbing heat and at the same time excellent as a structural characteristic. So I've got a few slides here on the testing we've done. I'll go through that a bit more quickly, perhaps. This was the use of a starch filler that we used as a burnout material that actually allows some gradient to start occurring in the materiality. This is a time lapse of a dedicated drawing process that we were working on that was measuring temperature, humidity, moisture content through that tile. And with the green clay, it was very difficult because it just wants to crack, and we did a lot of experiments of actually embedding sensors right into those tiles to see what was happening with it. And at the end of the day, what we had done is done 5 experiments, 5 different wall conditions that allowed us to start to suss out what the interactions were. This was actually achieved on that framework in the upper left-hand corner. There's a set of 16 sensors, I think, equally distributed across that wall. And then over time, we were measuring, say, either heat or moisture, and in one case combined what was happening in that wall. So this usually gives you a table of numbers that you probably know if you've done any sensoring work. We started with just the frame itself, and then we started using artificial inputs, in this case a theater lamp to replicate temperature, and then spray to represent moisture. This is early green clay. And then this is starting to look at the moisture within the green clay. And this is the combined reading. So a lot of that had to do with developing this idea of how does one visualize. And we were very kind of concerned with taking the idea of, say, temperature and humidity readings and finding a way to kind of clearly represent that back to ourselves and hopefully to others. So work done on the surface. We also did a series of exploratory panels developing surface patterns. We used grasshopper quite a bit. In feedback, then we started to look at changes within our monitoring system, our feedback system. So the use of vectors to start to indicate direction over time. This was very interesting. At the end of the day, I think what I remember most, or what I think has the most potential, is this idea for real-time feedback in a wall. That if you have a sensor system and a series of inputs onto that wall, then over time, this was actual decay, that light source had been turned off, but you could actually look at that delay as it was happening. So that's a little bit speeded up, but the idea was that you could actually watch that wall condition change. You could watch the moisture penetrate through different directions, if you like. So this idea of bentonite was actually very difficult to work with. We've got some ideas of how we'd like to move forward with that. And of course, we'd like to thank our sponsors. Right, that's it.
Okay. First, just want to say thank you so much to Stephanie, Georg, Laura, and Omar for the invitation to come and speak with me today. As Mitch mentioned, I am an artist. I come at dealing with ceramics materials from a very artistic perspective. And it's been fascinating to see so far the other presenters. It's been wonderful. I live in Madison, Wisconsin, and I'm an artist there, and I teach at the University of Wisconsin-Madison, mostly undergraduate courses to ceramic students. And one of the major questions I return to in my inquiry as an artist is, what is the relationship between an individual person or object and a larger system? And how do objects connect us with the limits of physical space, much as buildings do? What might the material of clay and ceramic offer to reformatting the boundaries of architecture? This image of my colleague Arnold Schwarzenegger here pressing his hands into a clay slab resonates with these questions on a multitude of levels. One of the things that I love about ceramics is that it has the opportunity to record the hands of the maker like no other material quite can. And when I began conceptualizing what I would speak about today at this colloquium, I researched and collected some of what I consider to be the greatest examples of the application of ceramics in architecture, which resulted in collecting more than 90 images of sculptures, toilets, cladding, tiles, and designed objects, about all of which I found myself to be equally excited. And as my abstract and title allude, I saw the initial thread between these interests as focusing on transitional spaces in architecture. But after further reflecting upon the images of my interests, I found myself drawn to clay and ceramics as it relates to architecture as more durational than transitional. Personally, I find ceramics to be most interesting when it's used as a tool over a period of time. This presentation, therefore, will focus on curiosities into artworks that appear to be amidst the relationship between architecture and ceramics. Their collection really doesn't serve to underscore a thesis, and I would say that I'm much more an enthusiast than I am an expert in the crossover territory between these two disciplines. I more so aim to expand and explore this shared terrain by looking into places that I see architecture in ceramics, or ceramics that uses architecture in unexpected ways. Some of these artworks I've seen in person, some I've curated in exhibitions, some I've made myself, and others I've contributed to collaboratively. This is one that I've only read or heard about, and it's called The Yielding Stone by Garófalo. It was produced in 1992 and encapsulates and epitomizes my current preoccupations with the clay material. As I mentioned before, ceramics, materials, and clay specifically captures all intended and unintended action taken upon it with a remarkable clarity. And it's an amazing conduit between the actions of a human being and a larger controlled ecosystem. In this exercise, artist Garófalo pushed a ball of plasticine clay equal to the weight of his own body around the streets of New York City and eventually into the gallery space at the Museum of Modern Art. This piece and the very architectural ideas of a one-to-one relationship with space and form is foundational to my understanding and curiosity into functional objects such as bowls, plates, and so forth. Without being elements of civic design, a streetscape, a duration of time, or a human body, this object is instead the interaction of all of these things. Although the ball is the weight of the artist pushing it, it is anything but a metaphor. My acquaintance with the architecture department here at Buffalo comes from my way of works with comes by the way of the works of Stephanie Davidson and Georg Rafailidis of Touchy Feely. This found space tile series was first produced during a residency at this amazing artist in residence program, the European Ceramics Work Center in Den Bosch in the Netherlands. Here, body shapes pressed into hardening bags of plaster yield shapes that mediate the connection between body and wall. Clay's opportunity to capture unique indentations are enhanced when placed amidst a field of more conventionally shaped tiles. This opportunity for clay to both adhere to convention and perform in a fundamentally individual way is an enticing proposition for the future of the material. The haptic poetics of these tiles drew me to curate Davidson and Rafailidis' work into an exhibition titled FFC I curated last spring that featured 3 creative entities who were alumni of the European Ceramic Work Center. Also by Stephanie Davidson and Georg Rafailidis, this work, this time with their student Matt Myers, was also featured in the exhibition. 832 Elmwood Avenue features a form-finding exercise in mold making that begins with a scaled-down wooden prototype of an actual address here in Buffalo. So to unpack this tile a little bit, mold making process was employed whereby portions of the mold were themselves cast in ceramic. In the image on the lower left shows some of the mold parts of an original house prototype cast in ceramic, glazed and assembled together. So up on the top, there's a wooden prototype of which a mold is then made out of plaster, and then certain parts of those plaster molds are then also reproduced so that they could be cast in clay. The unanimity of the material and surface sensibly aligns the 2 series of forms and implies the possibility that both can be model, mold, and actual structure simultaneously. This piece proposes the structure as building from a specific place that is still in the process of becoming and developing further into existence. This process of form finding could continue in perpetuity as a model, as a mode of developing a site or a structure. To jump back a couple decades now, this is Art Project 79 by Marek Sekula, who's an artist and designer. He's fascinating, he has a great website. I highly recommend taking a look into it. This is also a site-specific project that utilizes partnerships with a local factory to produce the most basic architectural element of the brick. And I wanted to show this specifically because of the connection between this program and Boston Valley Terracotta. This is a precedent for such a thing. This was in La Jolla, Curitiba, Brazil in 1979 and marks the location of an investigation into local material and found form. Secular writes of the project on his website that, quote, clay, the material was moved from the earth from a geometric formation found on a vertical side of a local dirt road. So this is just a wall of clay that's been cut away for a road. He continues, this material was transformed and pressed into 1,140 standard clay bricks in a nearby brick factory. Each brick was imprinted with logo Art Project 79 and outlines of the shape from the wall formation. Then the bricks were fired to 1050 centigrade in the factory kilns there. The fired bricks were then transported to the project site and built into the empty space from which they originally come in the form of raw clay. Each of these individual bricks from now on will carry into the future the information and the data of this project as a permanent time-sustaining document. He calls it the archaeology of the future, which I think is a really fascinating title and kind of plays in a lot with what's already been presented so far today. The use of the brick here interests me as a way to transform the original site, not by adding to it, but by responding to its existing material qualities. The artistry of this process seems to lie equally with Sekula's incidental observation of the site, as it does with the will and interest to transform its materials into a unit of indefinite utility, meaning that the bricks can be used again and again. I was first exposed to Sekula's work when I was a graduate student at Cranbrook Academy of Art, which is where I went to school outside of Detroit, between the years of 2007 and 2009. I was eager to go to Cranbrook partly because of the history of the collaborative projects between the departments of ceramics and architecture that took place there. And this is an example of one of those. Within the first 2 weeks of our graduate studies at Cranbrook, my classmates Brian Janewski, Justin Richards, and Andrew Ippoliti and myself, we began working together towards an exhibition that was titled Reinventing the Brick, that featured collaborative teams of students between Bill Massey's architecture department and the ceramics department that was led by Tony Hepburn at the time. The exhibition echoed similar collaborations and subsequent exhibitions earlier in the decade at the European Ceramics Work Center, where Tony Hepburn had been an artist in residence in 1998. So there's this sort of web of connections developing here. This shows a little bit of the process that we first went through to produce the slipcast bricks. Various different prototyping modes were used, and we wound up slipcasting them first in earthenware. Seems like a long time ago. During 2010 and 11, Andrew Ippoliti, who's seen next to me in the prior slide, he was studying the relationship between ceramics and architecture in dynastic China with the William J. Fulbright grant that was in the country, in China. So during that time, both he and myself held artist residencies at a place called the Pottery Workshop in Jianajian, which is this town with a very immense and amazing rich history in ceramic production. And it was there that we continued to work on this module. We continued the ongoing collaboration with Janewski and Richards and worked with the manufacturer there to produce 500 slipcast porcelain modules. You'll see these throughout the next series of slides. Each one of them has 14 main surfaces and is designed to combine with itself to produce multiple permutations of form. So these objects don't feature any sort of erratic difference in color or texture, but instead really showcase their sameness in form and surface. They're all unglazed and fit together without using mortar. Their 4 different notches facilitate multiple interactions that we still are figuring out, discovering. Every time we put these together, there's something new that comes up. And I think that's partially because of the 6-sided honeycomb shape that's so ubiquitous and seen so many times throughout the history. It was featured in your presentation quite a bit. It never really closes itself off to create any sort of finite polygon, which is it's kind of amazing. Very simple, but. So these 500 bricks have traveled all around different universities in the U.S. and have been installed by members of our collaborative team, working each time with students, instructors, and preparators at the various locations. This is one in Murray State University in Paducah, Kentucky. Sometimes, as you can see in the upper right-hand image, the materials bring out more animated qualities, or the formations seem to bring out more animated qualities in these modules. And at other times, we experiment with restraining the possibilities that are inherent within the system. They lend themselves best to horizontal orientations that are more suggestive of landscapes or cityscapes. Their format and modes of interaction includes incidents with a larger prearranged system. The form of the installations take is largely in response to the space in which they're situated and the variable of people involved in arranging them. There's no real fixed instructions that go along with this project. But at this current stage of development, these objects are much more rhetorical than they are structural, and their unanimous surface and formal qualities championing the flexibility over specificity. This is a piece by artist and designer Whitney Lowe, who lives in Portland, Oregon. It's titled Asphalt No. 1. And it's a collection of individual tiles that were modeled after a tar-covered fixed crack found in an asphalt parking lot near the artist's home. So you can see how this kind of goes together. The straightforward and yet obsessive goal of arresting these cracks in the parking lot incidentally produced a system of information unbeknownst to the repairer. inserting himself similarly to Sekula as an artist into the process of capturing, mapping, and reproducing the system of individual components that make up a whole. When you transform the cracks onto the backside of the clay slab. So it's incidental and kind of interesting to me as a ceramist that he did this not by cutting all the way through and risking the curve or mark of the knife. He just scored part of the way down in the back of this slab here. And the slab was constructed by him such in a way that just the drying process would allow it to crack along those lines. So it really reproduced something nearly to the exact design that was incidentally on the concrete. Lowe struck the balance with this project between the one-to-one incidents present within the Orozco piece and the artistry involved in executing the design. Ceramics here is the ideal go-between material and can capture the moment when incidence disrupts a system, reconstituting the action back to us with its full fidelity. As with the infinite jeweled brick modules in the preceding images, the monochromatic nature of Lowe's Asphalt No. 1 draws our attention to the formal nature and the landscape of the individual modules. Here, Lowe utilized and worked with, rather than against, the material tendencies of the clay to achieve the uniqueness in form. So unlike the previous examples of the monochromatic works, this is an image of Pritzker Prize-winning Chinese architect Wang Shu's ceramic house, and it's clad with thousands of individually glazed test tiles. By the way, these images are lifted or taken from cfile.org, which is a fantastic educational resource for ceramics of all kinds, but they have technology settings or technology pages and pages on architecture and so forth, so I highly recommend looking into it. So Wang Shu says of the house, and this is on C-File as well, the small house of 100 square meters, which is a cafe, I decided to make it a container. Whether it would hold wind or water is completely determined by intuition. Where a design will start is often accidental. For instance, in this case, I can explain it by the form of an inkstone from the Song Dynasty. The inkstone is made for the function only. Its surface is made of two parts. One is comparatively plain and the other is a slope. The plain part is for storing ink and the slope part is for dripping ink. I asked myself what I would see standing on the surface of the inkstone and what from the bottom. And I guess as the inkstone in this case was made of pottery, it reminded this artist of a friend who is a ceramist who was in the process of producing thousands and thousands of these small test tiles, which you can see right here. So this idea of the test tile as this arresting moment of fluidity within a glaze was something that was really inspired to this architect for this particular work, and again sort of echoes the incidents present in prior images. I was really interested in how this might also sort of serve as a metaphor of types to the different fluid interactions that might take place inside the coffee house. So I couldn't help but think about this exercise by artist-designer Alan Wexler, where he brilliantly uses the ceramic objects here to draw attention to the consequences of sipping coffee out of turn during a conversation, just by simply connecting all four coffee cups into two, which of course, if somebody goes to sip while their other company is not, then equilibrium kicks in and the incidence of the situation kind of takes over. And the functionality of architecture helps people understand how to use it. and more specifically, a large part of the social contract under which we live, I believe, as a society, is determined and implied by the structures and spaces we inhabit and occupy. So the coffee stains left on the table from this exercise were utilized to produce a new set of coffee cups with allegiance to the performed actions in the experiment. Wechsler, with his characteristic mischievous diplomacy, examines and makes only minor adjustments to the structure of the table to highlight the actions and all of them, the adequacies, the inadequacies, and all of the users interfacing with his design. He inserts himself as an artist to produce objects that do not deny, but instead record and respond to these messy foibles with allegiance. Wechsler's extruded objects resemble a miniaturized cityscape that responds to the actual rather than the ideal relationship between individuals. Much like Wangshu's ceramic house, Wechsler's coffee C6 level uses the fluidity associated with ceramics as inspiration towards vessels that shape human interaction. So now I'm going to get more into showing some of my own work. The relationship between the ideal and the actual that I mentioned during discussing Wechsler's piece was central to a recent exhibition of my artwork that was titled "Ideally It Would Be." This is an installation image of an exhibition at Page Bond Gallery. And many of the works in the exhibition used clay as a material to respond to specific aspects of the architectural space, much as other of the works that I've presented so far. This installation, or the space, was an odd and triangular shape with walls that included a peculiar detail of line that you can see where baseboard trim would have fallen to mediate the connection between the floor and the wall. Standing within the gallery space, which is the ultimate mediation space between artworks from artist studios to the public, and looking at the baseboard illusion, I began to ask myself the question of what could really happen if this mediation device would turn into an object itself.
We're over time.
I know. I'm getting there. Okay, this will be my last slide here, or my last series of images. So, yeah, I can't give it up that easily. Okay, 2240. So, during a couple of years, I worked at residential remodel. It was construction was constantly sort of reformatting pieces of lath and plaster into these dense sort of trash cans before they go away, and got really interested in that. And here you can see basically what I did was extruded the perimeter of that whole gallery space in 3 separate pieces that then were rolled back on themselves and placed next to the gallery, in which they, or placed next to the wall that they were associated with. So this is a 32 foot long piece of baseboard clay that was wrapped up and positioned next to its wall. Okay. Let's zoom through those. Okay. Thank you guys very much.
If everybody would just hang out for a few more minutes, I'd like to ask questions from the panel. Ask a question to the panelists and then ask a question to the audience. You mentioned the European Ceramics Workshop.
Yes.
What a great place it is. Every time I get together with John Krause, the president of the Boston Valley Terracotta, he says, how can he do that here? And that's up to me and Omar and Dean to figure out. But if you could wave a magic wand, both scientists, historian, interested in ceramics, what would a workshop look like? What would the ideal facility need to have for you to explore? I saw Brian's material and I thought of all these macro plugins like Ladybird, and they're all macro. They don't really deal with the specifics of the material. They show where the sun will shine and where it won't. But if you wanted to do more testing, what would the ideal workshop, studio, Lab B, first semester. Oh, there actually are seats. Look at that. And then, if for the audience members, student and faculty alike, what would you want to do? How would an internship, when you've got the chance to get your hands really dirty, why not? You know, off the keyboard and into the mud pot. You know, think about the kinds of things you would want in terms of resources, both intellectual and crafting and all that. Is that a reasonable question for a diverse panel?
Yeah.
Miguel, you want to start?
I'm still thinking, so.
Oh, all right.
Okay, at Dalhousie we do a lot of design build, so it's a very appealing proposition to me. And I think there's something for architects where if you can build it, you kind of prove it. That's one way of thinking about architecture. So I think that for me what would be very important is it wouldn't have to be a science lab on site, but there would certainly need to be some facilities that one could look at. I mean, we're talking ideal, right?
Yeah.
So spectral microscope start at about $1 million, but that's, you know, I mean,
Well, tell me
It's
what
always
you want.
nice.
Don't put the price in.
so you know, it would be very nice to be able to have, you know, I think a place where a multidisciplinary team could meet and have enough processing facilities there that each one could work in their own separate ways. And so for us, that would be computation, science and materials, and of course ceramic production. The other thing I would say though, that it would be very nice to be able to work through scale, so that you could start at a very small microscopic scale. You could, you know, you could work with tiles, much like a regular piece of canvas, and then you could start to explore what that means for architecture.
Do you really need an SEM while you're going? Scanning electron microscope? Do you really need a test wall with X number of sensors, you know, to sort of build it up?
Yeah, and it'd be wonderful if there was some of the land around that factory that one could start to test instructions with.
Oh, we've got lots of land. It's a matter of the snow covered.
But that would allow us to actually see what the relationship between sun and precipitation is, you know, in the real world rather than safety.
Okay.
I would say that that's the first thing that came to my mind, and it's something I've been thinking about a lot. And there's other people there's precedents for this, like Andrea Zitel's project and so forth. But I think it would be great to be able to actually see, from the perspective of someone who's been a builder, like what the effects of these of seasons over multiple years would be, and it would be on different materials, and specifically the connection between whatever materials are involved, in ceramics or.
Well, are you talking to have a webcam sitting there looking at it, or?
No, I mean like this and
More
really
towards sculpture.
walking around and yeah, almost like a sculpture park where you can just go out there and really assess what's going on with maybe a mobile diagnostics kind of unit that would allow you to measure the types of amazing depth of information that you're getting from what it is that you're doing. So like something that could go out in the field and really like evaluate what these buildings are doing or systems are, even if it's not a building.
Not to discount sensors. I mean, that would be wonderful to roll into it as well. So it would take on both a web presence and a reality.
Right. Well, you wouldn't be able to go walk around and see it in the snow. Depends how tall it is. It's 5 foot of snow and all that. So you may prefer to examine the effect of that much snow on the wall from a remote, secure, undisclosed.
Those few days in November.
Okay.
To me, it would be thinking in general terms, not specifically for anything in particular. I think it would be, there would be two issues, I think. One has to do with a collaborative situation where people from different backgrounds can actually meet and exchange ideas. I think the more the differences, the more interesting the possible production. And the other thing could probably be, or could have to do with separation between thinking and the making in terms of space. I think it would be interesting to have a place where discussion, thinking, in a more
good suggestion, you know, in some ways we're trying to reduce the separation, speed the feedback loop, saying, you know, nice drawing, but can't do it, or something like that. Right? Now, I asked you as you were coming up whether you were familiar with the Spanish ceramics industry funded projects at Harvard Graduate School of Design, and you are. But what would make this different? I mean, we're as good as Harvard, they just don't know it.
What sense?
Well, this workshop, I mean, I see a lot of robotic.
Between this theoretical thing and
Yeah.
the one at Harvard?
Yeah, what is,
Ours is much better.
what?
Ours is much better.
Uh,
Theirs is more of an agreement. We're actually.
Going to collaborate.
No, I think that they're, for what I know, their collaboration is more, I'm going to be a bad person, but I think it's more of a name issue, a tag issue. I don't think there is a great production. And in terms of collaboration, I'm not sure about that.
You can see anybody who voluntarily lived in Buffalo is really pragmatic.
Are you talking about the robotic wire cutting lab in Harvard?
Well, I've seen a variety of things where, you know, they break all the OSHA requirements and the guy holds the clay in the robot, cars.
Yeah.
And then I've seen some tile making things, you know, different patterns of tile, robotic arms, I believe. And, you know, this makes tile. So I've seen mainly applications of robotic arms sponsored by the Spanish tile industry. And I'm interested in a little bit more practical, scalable type of thing.
I think it's interesting, it's interesting to see, and I've shown some images about this, and I think that the tradition in Spain, just in case this adds something to the discussion, like there isn't that much exploration in 3D and you know this kind of software kind of new possibilities. I think the ways the Spanish architecture is exploring is by changing the position and changing the arrangement of almost pre-existing pieces rather than doing research like the one you presented on my perspective. I think that's fascinating, but I don't think that's happening so much in Spain.
Well, Gelly, you know, he's quite interesting.
Yeah, but he's like very unique, you know, very.
I'd just like to go back to your comment on Harvard just 1 second though. I think we worked with them in Troy, and I also had that impression that it was very about shape-based combinations and being able to, you know, almost like a kind of digital carver and use that tool.
Exactly.
But I think going back to your point, you know, this idea of artistic integrations, maybe that space that you're talking about is something that allows, I don't know whether, you know, it could be like an internship like you're doing now, or it could be artist in residence, but I think it'd be wonderful if that idea of artistic integration, like groundwork, you know, could actually filter into it.
Okay, thank you. I'm sorry Bill Carty's not here because, you know, I know he's been talking about, what did you call it, you know, the composites that go into the clay, and he's been talking about absorbing moisture and reducing the air conditioning load.
I think one of the greatest things about the European Ceramic Work Center is just the way that it's organized. I mean, and specifically, it's not just the way that all the workspaces are organized, but it's the way that the residency is situated such that there's always somebody coming in and always somebody going out. And it makes it so that, yeah, maybe it's difficult when you're in there to do like a long-term collaboration with another resident because of the timing of their residency. But on the flip side, it's really amazing because there's always this kind of new energy and ideas that come in there. And ceramics, one of the things that I think is most characteristic, thankfully so, of ceramic studios is that it requires a certain amount of communal interaction in order to exist. And I think it's important to keep that in mind as we move to a place that does involve more maybe machines that can be operated individually. is that like it's really great that people sort of have to wander into each other. It's kind of like the way that architecture is set up for different companies in Silicon Valley, where like it's made so that people have this sort of incidental relationship.
Yeah, the happy accidents.
Yeah, it's really
I hate to cut you off again, but let's get together afterwards. I saw at least one hand out here.
Yeah, just in terms of John Krause's question, how can we get this? And it was so interesting that the answers directly went into the realm of equipment and facilities, when I just wanted to say basically what Ari said, and you can speak to it very well too, that something that I took away from the European Ceramic Work Center was really the culture of being there and having techniques, having crash courses, and so many techniques, and developing very quickly a respect for these materials and techniques, and then being surrounded by very dedicated practitioners of all kinds, artists, industrial designers, architects, and having a constant exchange, even if you're very antisocial. There's a 10 o'clock coffee time, there's a communal dinner, and having, because it's a residency, it's so intensive that it's all focused on ceramics all the time, and that made a big difference in the culture and the commitment to projects versus when people go home and go to their regular lives and then touch base with you in a month and a half or something like that.
Anybody else who's got any questions or suggestions? Well, anybody want to sign up? Fellowships? Yes.
Yeah, I'm curious, maybe less for Brian first, and maybe you could answer this question last, but actually for Ari and because you don't talk about technology in your presentation, but I'm just curious of what, let's say both of them seem to talk about ceramics as if it's something timeless. So it exists in contemporary society, it has relevance, but is technology a game changer at all, or is it just something that's kind of parallel, existing on the side of other ceramics? Just in your opinion, in your own work, or?
I think it has to do with what I said before. I would say that most, with some exceptions, like Olivier or Daeda, for example, with very few exceptions, most of the work that is being done, the explorations in contemporary architecture in Spain, I'm talking about, is very low tech in general. I haven't seen a lot of research like we've seen here, the exploration of the material from a microscopic scale. So I think in that sense, the industry is not the industry, but the approach of architects more than the industry, because then there are all these big companies that are, in China and here, and they are everywhere. They sell very specific, tiles and everything. But in terms of architect practitioners who are approaching the exploration of space through different ways of using ceramics, I think they are always approaching the process from a very low-tech perspective, which is something that it's quite different here. I think here there's a much broader approach in terms of the exploration of how the material behaves and how things can be explored and used.
Yeah, like a question on technology. I think that it's really important to sort of always sort of question what your immediate inclination towards a material would be. I went to school at Oregon College of Art and Craft, and definitely was trained with the idea that making something by hand was amazing, and it really is. It's incredible. And there's also a technological sort of breakthrough that's happening with ceramics now. It's going on all over the place, and it's amazing and inspiring. And for me, I enjoy using technology in my own work, not the work that I showed here, but and I always sort of question, okay, if I'm using it, why does it need to be a part of the process? It's like, what can it help me do that I can't do with my hands, and what's the significance of it towards this object? goes really on a project by project basis. I recently did a project not in ceramics, but one that where I worked with the assistance of a guy in the human computer interaction department at the University of Wisconsin by the name of Sean Andrist. And he and I had approached him about asking him if I could wear glasses that could sort of scan my retinal pathways and throughout space and then produce an object based on that. So we worked together and it was great. Something happened, but without that, yeah, we always use the mechanics of our eyes to sort of observe and inform our hands and what we make. But there was something about using the technology there that seemed very specific to it. So, I mean, I think more broadly, I never think of them as being sort of binary, even though I know that I'm talking about that, but I never really think of the one as discontinuing the use of the other. It seems there's so many artists that use both really, really well.
We've got one more question. Dean Shibley's going to wrap it up for us.
Thank you all very much. I'm curious about how scale plays into experimentation with both technology and material properties. That full-scale testing versus what you could do at a lab bench. And if you're thinking about a laboratory and engagement, what can you do small scale? And what can only be done scaling up to something closer to full-scale production? And how does that play into your thinking about advancing the field?
Yeah, I just go back to your question for 1 second because I think it's tied into yours in some ways. In some ways, what I see as the value of technology or material sciences, perhaps, is a knock-on effect or a trickle-down effect. I mean, ceramics is doing a lot of wonderful things in a lot of diverse sectors right now, from flexible armor, say, to ceramic engine blocks, and so it kind of leads you to the question about what is ceramics actually. Like, it's actually a hybrid material very much now. So I think a lot of that is just unattainable for architects at the moment, but we don't know where that's going. And to be aware of what it can do, I think is a really important step in the sense that we can actually start to consider how to do or how to achieve those effects, maybe in cheaper or more trailing edge kind of ways. So architecture, if you like, is some sort of combination of being very aware of what's happening in high technology, and then also being kind of very frugal, if you like, and taking a combination of say, the materiality of it itself in its raw state, the low tech, if you like, and finding the happy medium for what that experiment is trying to do. The kind of question about what we can achieve on a small scale, I think, in the laboratory is material combination. So if I want to look at hybrid materials and how they perform, I think just with that distant material, I can get to that much quicker. Because we know the operative scale for ceramics is between the micrometer and the nanometer. So I really want tools that can show me what's happening at that scale. The advantage of, say, scaling up, like doing the wall, is to start looking at material in its geometric patterning, right? In its kind of system-like approach. And I think the idea of scaling up even farther to the building, like all the beautiful ceramic buildings we've ever seen, is the kind of the quality of what it's like to live in them. Are they really doing what we say they're doing?
Yeah, besides this, I think it's a very interesting moment right now because for 5 years, there is association called ASPE, which is the National Association of the Industry of Ceramics in Spain, which is quite powerful, and they are actually the ones who are signing the power in these agreements. It's interesting that in the last few years, very interesting things are happening with ceramics. This is not an isolated thing. This Aster thing started to develop really in a very large sense in Spain. They started to have agreements with Harvard. We are here today talking about all these issues. And it's interesting because in Spain, even though I've shown some of the tradition and a very natural relationship between the contemporary and the past. Because of the housing crisis, where we have crazy buildings like Terracotta, which cost 3-5 times more than it was expected, there is a very clear return to the use of very low-tech, low-profile materials in buildings. And people like Luis Fernandez Galiano, who's the editor-in-chief of very well-known architecture magazines like Arquitectura Viva, AB, and so on, he is actually pushing quite hard on this turn into looking at very basic, very simple, these passive systems to reincorporate them in a more responsible type of architecture, which is very illustrative of the situation. And I think it's all very interesting in terms of momentum.
I'm going to wrap it up. People have been very patient. I just want to say another major issue. You can get those little wafers. Can you manufacture those wafers at any type of size? There you need industrialists who know the process and how that might be transformed from the laboratory, much on the Silicon Valley model. How do you do it big time so you get economies of scale?
Even Bill Garden, is priceless in our garden.
Right, we remember that. Sorry. All right, thank you all. Appreciate your time. Omar, how much time?